Welcome back. We left off reviewing many basic geometrical concepts and formulas like the distance formulas, all types of angles, similar triangles as being part of mathematical transformation, especially the dilation. In particular, when you enlarge a triangle or a polygon, or you contract it and you reduce it. And we said the way to identify this is through the corresponding side. The sides are not of equal length like in a congruent triangle, but they are in the same ratio for the corresponding sides of the two triangles. And we said that this also applies to the perimeter, the angle bisector, the medians, and the diagonals. And we said that this is the SSS being the same ratio for the corresponding sides, or SAS, which is common sense, side, angle, side. And then if you have two angles that are congruent, that means the third one is congruent with the corresponding angle of the second triangle. We said that this all stems out of interconnecting and linking compound angles of trigonometry and geometrical constructions. And as a result, we did set up the compound angles, or the crab angle rules, of the sine of theta plus beta and the sine of theta minus beta, or cosine of theta minus beta, being sine of theta plus beta. This is the gullible one. Remember this one. This one is super important because we're going to use that concept to figure out the double angle, the half angle, many other identities, just by following this crab partner, going side by side. Sine being the gullible does not change the sign, being SIGN here. It stays plus, and if it's minus, it stays minus. And the cosine of theta plus beta is the selfish one, goes cosine theta, cosine beta, does change the sign, and then tells the sign, the ratio of sine to, which is opposite divided by hypotenuse, to come aboard. Okay? Having that in mind, we also, when we were doing simplification, we linked all that to what? To the special hexagon, the TSC hexagon, because you have your cofunctions here. You have TSC, sine, cosine, sine of 90 minus theta equal cosine of theta, tangent of 90 minus theta equal cotangent of theta. In quadrant 1, you know, they're all positive, and secant equal of 90 minus theta equal cosecant of theta. They're all positive. Now, this sine of pi divided by 2, or 90 minus, if you do sine of pi divided by 2, or 90 minus theta in quadrant 1, equal cosine of theta being a cofunction, this also comes out of the crab rule, out of this crab partner, because if you apply the compound angle theory to it, it's sine of pi over 2 times cosine theta. You don't change this, and then you go cosine of pi over 2 times sine of theta. This is z0, cosine of 90 is 0, and this is 1, so the answer equal plus cosine theta. Okay? Now, if you have that as sine of pi over 2, a plus theta, meaning an angle that is larger than 90 degrees, obtuse angle making a triangle. So it's in quadrant 2. Basically, this is going to equal what? Cosine theta, because the sine, even in quadrant 2, is positive. And if you follow the compound angle rule, or the crab rule, you're going to get the same thing. You know, sine, you don't change this, so this is plus. Cosine of pi over 2. Again, cosine of pi over 2 is 0, so you're only left up with cosine plus cosine of theta. Now, and this makes a lot of sense. Now, if you switch it, and if you go to cosine, the cosine of 90 degrees plus theta in quadrant 2 equals what? The cosine is negative in quadrant 2, so it's going to equal minus sine of theta. And this, even if you don't memorize it, even if we don't want to memorize it, we don't want to remember this, you can figure it out from the crab rule right away. This is cosine of 90 degrees cosine of theta. It does change the sign because it's selfish, and at the end it tells the sign to come aboard. This is 1, so we're left with minus sine of theta because cosine of 90 is 0. Okay, so it makes a lot of sense. All the rules are interlinked, and you know, now we're gonna get to the only rule that we're gonna memorize. This is the first rule after 15 or 17 lessons that we're gonna memorize, because it's the tangent of theta plus beta. The tangent of theta plus beta, think of it this way, equal sine of theta plus beta divided by cosine of theta plus beta, right? So if you apply Crab rule or Crab partner rules to the numerator and denominator, that's sine theta cosine beta, don't change, it's plus cosine theta sine beta. The whole thing, now you have one term, two terms, and in the new denominator you're going to also have two terms, but you're going to have them like this. This is the selfish one, cosine theta cosine beta, minus, you change the sign, and then you end up with sine theta sine beta. Now we need to divide the numerator and the denominator by cosine theta cosine beta. We're dividing. This is not something that you need to learn or even know how. The result of that, the identity of tangent of theta plus beta or tangent of theta minus beta, is something that, unfortunately, this is the only trig law so far that we need to memorize. But how did we get to it? This is how we got to it. Now we have four terms. We divide each term by cosine theta cosine beta. Now let's look at our numerator first. In the numerator, we have sine theta cosine beta divided by cosine theta cosine beta. The second term, cosine theta sine beta, the whole thing, cosine theta cosine beta. Denominator, cosine theta cosine beta, cosine theta cosine beta, so this whole thing is 1, and we have a minus, and then we have sine theta, and we have sine beta, the whole thing divided by cosine theta cosine beta. This makes a tangent theta or theta times tangent beta. And on top, look what's on top. We have tangent theta plus tangent beta. So the final answer of this identity, tangent of theta plus beta equal tangent of theta plus tangent of beta, 1. And then since the cosine changes the sign, the sign, minus a product in the denominator, the product of the two ratios, tangent theta times tangent beta. And this is the first, after 16 or 17 lessons, the first identity that unfortunately you need to memorize. Now if you go the other way around, I mean tangent of theta minus beta. This is tangent of theta minus tangent of beta, and 1 plus, the cosine does change the sign, 1 plus tangent theta tangent beta. Okay, now if you have a pi over 2, 90 degrees with a tangent, it doesn't really work very well, and that's how we also have to link other element. And when this works when you don't have, like if you have tangent of 30 degrees plus 45 degrees, which is 75, right? That equals tangent of 30 plus tangent of 45. You know the tangent of 45 is 1. The tangent of 30 is what? It's square root of 3 divided 1 divided by square root of 3, or square root of 3 divided by 3, and then 1 minus tangent of 30, which is a square root of 3 divided by 3 times tangent of 45, which is 1. This works here. However, if you have tangent of, let's say, 90 degrees plus 45, which is what, 135. Can you do it this way? If you go ahead and you put tangent of 90 degrees, what's tangent of 90 degrees? It's undefined because the sine is 1 and the cosine is 0. 1 divided by 0 is undefined. And, for some of you, if you know coding, if you study JavaScript, this runs as NaN, which is not a number. It runs as a string of undefined elements. So basically, whenever we have a plus pi over 2 or minus pi over 2 with the tangent, we cannot use this law because the tangent of 90 degrees is undefined, and undefined is just a concept, like the infinity. It's just a concept, okay? We can use it when we don't have the pi over 2. So when we have the pi over 2, what do? We'll get to that in a second. But now let's go back to that tangent of 75. Or let's do tangent of 15, which equal tangent of 45 minus 30. You know both of them, right? So this equals tangent of 45 degrees minus tangent of 30 degrees. And in the bottom, in the denominator, because the cosine changes the SIGN, I change that to tangent 45 times tangent of 30. And then here I have tangent of 45 is 1 minus 1 divided by square root of 3, and then 1 plus 1 divided by square root of 3. If I want to bring that square root of 3 to the top, I end up with square root of 3 minus 1 divided by square root of 3 plus 1. Now, you go to the ABC if you're doing, let's say you're taking an exam or a college test or a pre-calculus test, and you don't see that. But you should know what's square root of 3. If you're in grade 12 and, going to college, first year of college, you should know that square root of 3 is 1.7320. So they expect you to know that this is 1.7320 minus 1 divided by 1.7320 plus 1. And on top, you have 0.732, and the denominator 2.732. You look at it, they want to test your knowledge of basic math, basic blocks here, elementary and middle school, as in where is the dividend and where is the divided. 6 divided by 3, how many times 3 goes into 6? The small one goes into the large one. However, here the dividend is the smaller one. So how many times does 2.7 goes into 0.7? If you cannot figure it out this way, bring the decimals to the sides. What does that mean? Make it 70. So if you make it 70, this one, 1, 2. So you're bringing the decimal to the right 2 times. And if you want to make this 27, you're breaking the decimal to the right 1 time. So basically, in total, you're bringing the decimal to the right 1 time, right? To the right. So when you're done, you have to bring it back to the left 1 time. So now I have how many times does 27 goes into 70? How many times does 27 goes into 70? 27 times 3 is 81. So it's about 2.5, 2.6. So the answer is 2.6. But since I went 1 time to the right with the decimal, I have to go back instead of 2.6 to the left 1 time. So it's 0.26. It's around that, 0.26. And this, you should see something like that in your ABC options. If you forgot that, let's do another one. Let's say you have 0.431 divided by 1.430. Yeah, that makes sense. Okay, so you look at it and you tell me, again, dividend is smaller than the divisor. How many times does 14? If I take 14 and 43, that's 14 and 42. 42 divided by 14 is 3. So I go to the right with the decimals 2 times to make it 243, and I go 1 time to make it 14. So in all, I went to the right one time with a decimal. So when I'm done, I have to go back to the left one time with a decimal. So how many times does 14 goes into 43? Around 3.0 something. So, okay. And then if you want to get back to the left, because you went to the right one time with the decimal, it's 0.30. So again, in your answer, you should see something like 0.5, 0.003, and then one of them would be 0.30 or 0.3. It's testing your knowledge of basic math skills. How do you dividend, divisor? How many times do you go with the decimal to the right or to the left? Okay. Now, if we did the tangent of 15. Let's do the tangent of 75. If you think of it as tangent of 90, again, minus 15, you won't be able to solve it because tangent of 90, again, is undefined. Now, but if you think of it as, if you tell me, okay, let's think of it as sine of 90 minus 15 divided by cosine of 90 minus 15. Again, you don't know what 15 is. You know 30, you know 45, you know 60. You still don't know that. So how do you solve it? You solve that by sometimes doing the reciprocal, meaning, a tangent of 90 minus 15 is what? Is tangent of, in the hexagon, tangent of pi over 2, or 90 minus theta. It's cotangent theta. So it's cotangent 15 and plus cotangent 15. Now, they should either give you what's cotangent 15, or this should be one of your answers in the ABC choices. So basically, when you don't have it, it's either given to you, or you need your calculator, your scientific calculator, to get your cotangent 15, because you don't know this one. Now, in the exception that is 90 degrees and the tangent, we can think about the reciprocal, like I just talked about it. What does that mean? That means in this hexagon, we already know that tangent of pi over 2 minus theta, tangent T tangent of pi over 2 equal cotangent of theta. And if I go tangent of pi over 2 plus theta in quadrant 2 for an obtuse triangle, I should get minus cotangent theta, because the cosine is negative and the tangent is sine divided by cosine. So that makes a lot of sense. Now, if I go cotangent of pi over 2. See, here I'm running and I'm going with all these things just by following what's the reciprocal, where is the location. The only thing I memorized so far is just that compound angle tangent of theta plus beta identity. Okay? Tangent or cotangent of 90 degrees minus theta equal tangent theta. We know that from here. This is the t, this is the cotangent. They are cofunctions. There is one between them right here. Okay? So if you go cotangent in quadrant 2 of pi over 2 plus theta, again, you're going to get minus tangent of theta, because in quadrant 2, the tangent and the cotangent are negative. Okay? Because the cosine is negative, and the tangent and the cotangent are made of sine and cosine. So one of them is negative. Positive times negative is negative. As simple as that. Okay? If we think about it as reciprocal, cotangent of 90 degrees minus theta equal 1 divided by tangent of 90 degrees minus theta. What's tangent of 90 degrees minus theta? We already established that as being cotangent of theta. And 1 divided by cotangent of theta is tangent of theta. And that's positive in quadrant 1. Okay? So when we have this 90 degrees or pi over 2 with the tangent, it's very easy to approach it with the reciprocal concept and, with location in which quadrant are we. And this also applies to the cosecant and the secant. If I have, again, this is my sine, cosine, tangent, cotangent, and this is my secant and cosecant, second to last. I have secant of 90 degrees plus theta equals what? The reciprocal. Reciprocal is here, where the 1 is in the middle. So there's 1 in the middle, so the reciprocal is your cosine. Cosine of 90 degrees plus theta. Now you can apply the Crab rule to this one. You do cosine 90 times cosine theta. You switch that to minus because it's the selfish one. Minus sine 90 times sine theta. And then cosine of 90 is 0 and sine of 90 is 1. So you end up with, because you have a minus now, you end up with 1 divided by minus sine of theta. Okay, and 1 divided by sine of theta is what? The reciprocal of what? Of cosecant. So this whole thing equal minus cosecant of theta. So secant of 90 plus theta equal minus cosecant of theta. And the secant is the reciprocal of what? Is the reciprocal of the cosine. And the cosine is negative in quadrant 2. See how they're all interlinked? So that's why it's minus cosecant theta, the answer, because the secant is a reciprocal of the cosine, and the cosine is negative in quadrant 2. That's why the answer is negative, is minus cosecant theta. However, if you go cosecant of 90 degrees plus theta, and you do your reciprocal, it's the cosecant is, this is your cosecant here, this is the sine. Cosecant is the reciprocal of the sine. So that's sine of 90 degrees plus theta equal 1 divided by cosine of theta. How did I get to that? You can go the Crab rule. Sine 90 times cosine theta, which is cosine theta, plus, you don't change the plus sign. You don't change that with the sine. Cosine 90, which is 0. So we forget about the second term. So 1 divided by cosine, this is your cosine, this is your secant. So they're reciprocal, the secant and the cosine. 1 divided by cosine theta is what? Is secant theta. And it makes sense because the cosecant is the reciprocal of the sine. And the sine in quadrant 2 is positive. Again, they're all interlinked here. And that's the beauty of all these. This Crab rule and the location of the angle and the reciprocal that we found in that special hexagon, everything is interlinked. Now, the last thing I want to talk about, I want to keep the rest for next lesson, is the way they ask you these questions when you're simplifying. When you simplify, or you have let's say, determine the angle or find out the value of an angle. Let's say it's something easy, sine of 135 degrees. Again, you don't remember it, you don't know it, you don't have to. Just use this, 90 degrees plus 45. You can use the 90 degrees with the sine. It's with the tangent that causes the problem because it's undefined, tangent of 90 degrees. So, Crab rule again, sine of 90 degrees times cosine of 45. Don't change the plus. The sine is gullible. Sine of 45 times cosine of 90 degrees, which is 0. So this whole term is 0. This is 1. Cosine of 45 is square root of 2 divided by 2, or 1 divided by square root of 2. Okay, or equals square root of 2 divided by 2. Okay, now, excuse me. Now, if you have something, let's say, a tangent, okay? This is easy because the sine of 90 is, it's 1. How about the tangent? The tangent of 90 is undefined. Well, how do we approach this? Tangent of 150 degrees. No calculator allowed. So what do? You tell me, oh, you just told me if I do tangent of 90 degrees plus 60, I know the tangent of 60, but tangent of 90 is what? Is undefined. So if I go ahead and I use this one and only one identity that I have already memorized, this equal tangent of 90 plus tangent of 60 divided by 1 minus tangent of 90 times tangent of 60. I won't be able to solve. I told you in the case of the 90, especially in the case of the 90, we approach it differently. We approach it with the reciprocal. So this equal 1 divided by cotangent of 90 degrees plus 60 degrees. Okay? And what's cotangent of 90 or pi over 2 plus an angle that's obtuse, in the second quadrant, the cotangent is negative. So it's going to be tangent 60 degrees or tangent theta with a minus because the cosine, that is, the cotangent is made of cosine and sine. So it equals tangent of 60 degrees. What's tangent of 60 degrees? Or if you look at it, what's 1 divided by tangent of theta? It's cotangent of theta with the minus sign. So that's minus cotangent of 60 degrees. You tell me you still haven't solved it. Yeah, I didn't solve it because what's cotangent? Cotangent of cosine divided by sine. What's cosine of 60? It's 0.5 or 1 divided by 2. What's sine of 60? It's square root of 3 divided by 2. 2 and 2, they, eliminate. So the answer is minus, because remember this minus 1 divided by square root of 3. Okay? So again, when you have tangent of 90, you need to use it to break an angle to make it compound. Just refer back to the reciprocals and to the hexagon. And you should be able to solve it this way. Last thing we're going to talk about, let me see here, what else do I have? Before we get into the double identity, I'm going to leave that for the next lesson. They give you something like, let's say, cosine x or theta. In many textbooks, they go with x as being the variable. Square root of 2. Prove that the given equations follows an identity. Okay? Square root of 3, what do I have here? Cosine of x minus sine of x. You want to prove that the given equations follow an identity. So how do we do that? We look at this. It's a compound angle. So let's, apply the crab rule. Cosine of x times cosine of pi divided by 4, which is 45 degrees, right? It's selfish. It's the cosine. It changes the key. It changes the code. Changes the plus to minus. So minus, and then at the end it tells the sign, please come aboard. Minus sine of x, sine of pi divided by 4. Now, what's cosine of 45 degrees? It's the square root of 2 divided by 2. So this is cosine of x times square root of 2 divided by 2 minus sine of x square root of 2 divided by 2, because the sine of 45 degrees is also square root of 2 divided by 2. So you take square root of 2 divided by 2 as a common factor, and then you do cosine x minus sine x. So they do follow an identity, which is the compound angle identity, okay? How about, let's do this one. Tangent, last one, theta plus pi over 4, okay? And equals 1 plus tan theta divided by 1 minus tan theta, okay? And they tell you, prove that the given equations, they follow an identity. So this is the only one that you had to memorize, tangent of theta plus beta. What's the memorization yields to tangent of theta plus tangent of beta, which is pi over 4 in this situation, divided by 1, the cosine, this is the sine, tangent is sine divided by cosine, 1 minus the product here. Tangent of theta, tangent of pi over 4. What's the tangent of pi over 4? It's 1. So that's 1 plus tangent of theta, and in the denominator I have 1 minus 1 times tangent theta, so 1 minus tangent theta. So it does follow an identity, okay? So they approach it in a, it's not a tricky way, just all you need to know how to link location of the angle, which quadrant, reciprocal ratios, you know your hexagon, know how to break a denominator or make a common denominator, know how to use the crab rule, the compound crab rule. And the only one we memorized so far is this tangent of theta plus beta, or tangent of theta minus beta. In the next lesson, we're gonna use the same crab rule that is universal, that is, the best rule you ever learn, and learn not to memorize in trigonometry, to figure out the compound angle that, they tell you the compound angle, the sine of 2 theta or the cosine of 2 theta using the crab rule. And, in many textbooks, they put it as an identity that you have to memorize, which you don't have to memorize, because in like 15 seconds, 10 seconds, you can figure out this identity without memorizing it using this simple crab rule. And we'll leave that for the next lesson. And thank you for watching.